Good morning, good evening, good afternoon, boys and girls. I know you're waiting anxiously for Tony, so here we go. And Tony is going to be doing our LMTV WTF, where is Tony Fortunato, and he's going to continue with his application baselining sequence, which, by all measurement, Tony, it was a hit last week.
Yep, everybody wants information.
Yeah, I never been. I mean, you're doing all the heavy lifting, but I feel like I accomplished something.
Of course, yeah.
I mean, what happened? You know, every once in a while, we like Tim said, you know, we don't try to improve. We just keep doing it, right, Tim?
That's right.
Yeah.
That's so what people, when I fall down on my new leg, people just laugh and say, "Don't help me up. Let me just get up on my own because it's more fun when I fall down again." You know?
So good afternoon, Tim, and good evening, Paul.
Hi, how you doing, Denny?
You know, I wonder if we should just take one day, do 24 hours of this, and just keep just take 2 months off. You know, it seems like it was just yesterday that we did this.
Just like that.
Okay, Tony.
All right, let's get cracking, folks. So today we're going to be looking at HTTP. I realized a lot of the notes that we had put out on the invite was quite all-encompassing. So instead of trying to do a whole lot of everything, I've pared that down so we can actually fit this in within a half an hour, maybe 40 minutes, and try to get you some information that you can use. So I'm just doing my screen share right now. There you go. So everybody should be seeing that. So just a few notes for the people who haven't attended this before. Nothing beats attending a live event, but if you can't make it, go to Love My Tool for the replay. We also get asked a lot, when's the next one? So all future dates and topics are also posted on lovemytool.com as well. And the Q&A icon, for the people that aren't familiar with Google Hangouts, there's a Q&A icon. You can post your questions, and I will answer them as I see them. I actually get quite a bit of questions after the event, but by all means, post them as you see them. So
and also Tony, you show us how to do a LinkedIn sharing, and so that's another way to LinkedIn turn out to be really popular among our viewers.
Yeah, good point. Yeah, that's right. It'll be posted on LinkedIn as well. So don't forget to like the video on YouTube, and of course you can share that on Google and LinkedIn and all that good stuff as well. All right, enough of that.
Give them your address so they can send checks.
Yeah, that's right. They can all send me checks and gold bullion. So about me, the presenter, for the people who haven't seen me before, I'm the Senior Network Performance Specialist. I'm with the technology firm. I've been training, designing, implementing, and troubleshooting networks since 1989, so that technically makes me old, I guess. Mm-hmm. I teach or troubleshoot on your network with your staff, your tools, and I do these customized on-site training gigs, which people seem to enjoy a lot. So a little bit about HTTP, the basics. I'm surprised when I say this out loud because it just sounds obvious, but you think about it, it's quite a revelation. HTTP, we use to send or receive data. That part's obvious, but it's not just for surfing the web. A lot of applications will use it on the back end, embedded, that sort of thing. So HTTP sometimes isn't you on your browser surfing the web. It can be used many different ways. It's also not just over TCP port 80, of course, that's the default. People immediately think of proxies and proxy port numbers, but no, some applications will just have a different port number other than 80 or 8000 or 8080. Again, it's HTTP. So for the purposes of this session, because again I'm trying to keep this relatively condensed, we're going to focus on the web browsing option. As far as all the other stuff I mentioned, those are great tail-offs for other sessions. So my test configuration, everybody loves a diagram. This is me down here in the corner. I'm going to go to thetechfirm.com. I go through this wireless access point, through the switch, through the router, internet, and off we go. This is an example of things I like to document for my customers. Nice, pretty picture, a few notes, like, for example, no capture filter. Up here, tips. If you want to eliminate all your local traffic from your trace, all you have to do is filter on the router's MAC address. And when you do that, then you only get the traffic in and out of the router, i.e. remote traffic. That's always a little tip I share with people that, again, people tend to appreciate, so you can filter out your local stuff. The anatomy of an HTTP connection. This is where the fun happens. One of the problems I have with HTTP is people try to analyze, troubleshoot, or baseline HTTP, Literally, that's the mistake. So HTTP relies on a bunch of other stuff. And I try to break this down into two scenarios. The easy scenario is broken. So if DNS doesn't work, if the ARPs are messed up, if TCP gets hung up, then things break, and then you go and fix things, and that's the good thing. The trickier one would be things slow down, or the path to things slow down. And then that way you're not broken, and you don't tend to fix it, and you get confused. So I'm going to break down these, in this example, these 4 components in a little bit more detail so you can better appreciate it. But all applications do this. Not very few applications will just have one protocol. They all rely or depend on other protocols, services, or servers to make the overall application work, okay? For example, DNS. So if you did capture some web traffic, the first thing you're going to want to look at is probably DNS. And this is in no particular order, by the way. So in Wireshark or most protocol analyzers, you can just do a DNS filter. If you have other types of tools out there, even application monitoring tools, they can do this as well. So this is a fairly generic statement. And you can see even here when I did a DNS filter, you can see your query and you see your responses. The thing that starts to get a little bit convoluted is when you have them bunched up, such as this one. You see the first query and the second query and 2 responses. The questions start to arise which belong with which. And this is where this number here that you see after the response, these numbers, these values, 0x, these are called transaction IDs. And most applications will have something like that. And you can use that to start to track and try to correlate what belongs with what. In this case, with Wireshark, I could do a filter on that transaction ID. I've got other videos showing you exactly how to do that. But in this case, by filtering on the one transaction, then this becomes more obvious. We see the query, we see the response, and on the left-hand side here where it says time, I've got the delta time, or as Wireshark calls it, the time between displayed packets. And in this case, it's 28 milliseconds. So you can see there's your request, there's your response, and this simple, very simple exercise, you can now, I call this tool and human calibration. You go back to your other tools. You've done this longhand, right? You go back to your other tools and say, okay, great. What did Acme report? You know, was it 28? Was it 50? Was it 16? Like, what are they doing? And then you can better understand how people measure response, because I'll tell you right now, not everybody does it the same way. So this is kind of critical. Do the math, figure out what it is, and then figure out how your tools report it. And I can't stress that enough. That's a huge point. If you want to find out how many DNS requests were sent, well, then you can just simply use this filter, and this will show you just the queries. And I tell people this starts to illustrate how much work is involved. And that's literally what I mean, work. So every time you do a query, you're going to get a response, and then you're going to move on to the next command. Well, guess what? If that query took a long time, or if you had a lot of queries, many queries, 50 queries versus 500 queries, well, the 500 queries is going to result in, guess what? Slower response time. So this is a great way to start to understand what are we querying. And I say down here, this is a great way of documenting how many external references the web page has. Sometimes it's simple, it's just a banner or something like that, but other cases it's another server, it's authentication, it's other things that it requires to move on, right? It's also helpful to see which browser extensions are loaded. So for example, with Internet Explorer, the default search engine is Bing. So you see all sorts of DNS references to Bing, the API for Bing to do the search. If you had Facebook little add-on, whatever you have, LinkedIn, all of those will come out on those DNS queries. And just so you don't think it's a Wireshark class, there's a screenshot from Network Instruments Observer, and it's the same type of idea. So we have the application DNS, it tells me how many packets, how many bytes, but here's the cool part, the response time, you see? So if I said it was 28 milliseconds and I come over here and I validate it and it was 28 milliseconds, then I know I do the same math that this tool does, that's all. Okay? No tool is better than the other. You just have to understand how it calculates these things. Okay? So if you need to analyze or check DNS response time frequently, you may find manually performing this exercise very time-consuming. So this breaks into 2 different topics. This is not only, I know how you did the math, but if this becomes an issue or something that you feel you should be monitoring, you might want to say, wow, is there a tool out there that will measure DNS response time, the DNS query, not pinging a server. That's not what I'm saying. An actual tool to measure DNS lookup, DNS response, or command response. I don't know, however you want to say that. And there aren't too many tools out there, I'll tell you right now, that specifically do that. So if that becomes something that you think is important, then yeah, you should have a tool that monitors that. And then from that same discussion, what do you do if the response time is slow? What do you do if you get an error? And all that good stuff comes out of that conversation. So the other thing that I want to talk a little bit about is DNS errors. Now, I try to categorize this into two basic conversations. There's the DNS error, such as the DNS service being down, and that's obvious because nothing works. But then there's literally a DNS error. You know, DNS telling you the name doesn't exist, for example. That's a different kind of error. And that's another thing that I try to get people to understand. You have to understand types of errors, because if you don't, then you don't know what tools will be able to monitor at that level. And I've had several engagements I've been on where the guys are saying, DNS, I can ping it, I can ping it, I can ping it, it's working. But no, the name, that specific name the application needed had an error or wasn't being resolved properly. So a couple of points here. Since DNS is UDP based, no error messages typically returned if the server is completely down. So it's not like TCP where you get a reset or a retransmission. UDP obviously does not do that, so you're relying on the application to somehow do that. In some cases, if just the DNS service is down, you might see an ICMP port unreachable message. And that's a pretty typical thing you'll see when a service or application is down. It says, hey, guess what? It says ICMP destination unreachable, port unreachable, and you'll see that in a few other screenshots, and that port correlates to the application port number, for example, DNS. So in this case, just to go through this trace file, packet 1, you'll see the lookup. This is the DNS that I put in, which doesn't exist, by the way. So I sent out this query, didn't work, and then you get these magical DNS MSFTNCSI, woo! And people wonder, what is that? It's not just me. You'll find that everywhere, and I'll talk about that in a moment. And then finally, you'll see the proper query response down here from 888. See that? So the point of this exercise is if you start following these packets, again, I'll go back down here. Number 1, you see the lookup goes unanswered. Packet 6, my computer tries to look up this DNS MS blah, blah, blah on the same IP address. Packet 7, we see my computer finally using the secondary DNS. And then number 8, it worked. But the main point of this exercise is not that it worked, but how long did that cost you? 6.5 seconds. So if I'm sitting there trying to surf the internet and I have these 6-second delays, guess what? There you go. That sort of thing, okay? When it comes to the ICMP messages, this is an example of that. Again, I picked a device that exists but is not a DNS server. And you can see I'm querying for myyahoo.com, and this device comes back, says destination unreachable, port unreachable. Now this gets very tricky because in the real world, a firewall or ACLs may prevent that message from coming back to you. So you might not see anything come back because it's ICMP, and some people block all ICMP, right? And then you just see the query nothing, query nothing, query nothing, and that sort of thing. Now down here, this is the other type of error I was telling you about. It's not ICMP. This is a query for Tony123abc.com, which doesn't exist. The DNS server went to look it up and said no such name. Now, if you looked at this superficially, you would say, oh, DNS came back in 61 milliseconds. No, 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 no. You have to look at the details, no such name. And if you open that up, you will actually find that, again, query response, no such name. So this again goes back to DNS analysis. When you do get responses, do you have a tool intelligent enough to say, yeah, I got a response, that was 61 milliseconds, but there was no such name. That sort of thing, okay? And not all DNS servers are created equal. And this is a very interesting problem I ran into a while ago that I'm going to bring up. In this example, you can see 888, which again is the Google DNS server, OpenDNS people call it, server that's publicly available. And everybody says, well, it's Google. It must perform better than, obviously, my ISP or my corporate DNS. And you can see here when we compare it, local DNS versus remote. So this top one is the local. And you can see here we're doing a DNS lookup and a response, 52 milliseconds, 49 milliseconds. And then I did using Google's 888, and it was 41 and 27. See that? So at the end of the day, the remote actually did perform slightly better than the local DNS. You see that? But it could easily go the other way. So and this is the caveat I give everybody, and I've just written another article about IP DNS on a Cisco router. Don't blindly believe that this is going to work the same way everywhere with the same DNSs. You have to test this. You have to find out what works best. So I'm a big guy on methodology. Here's what I got. Now go figure out what you got. I'm not telling you you're going to get this. Okay? The client was very close to improving performance by using a local DNS server because everybody was telling him just get a local DNS server. Well, guess what? The local DNS server might be undersized. It might not have great software. There might be all sorts of reasons why it's not going to work great. And don't forget about other name services you might have in your environment. LDAP, NetBIOS, WINS, all sorts of other ways of resolving a name. I've even seen the ON application that has its own proprietary name lookup protocol or routine. So you really have to be cognizant about how people figure out the name. You start to really get into problems when you have multiple ways of resolving the name, especially with things like IPv6, right? You might be resolving it over LDAP, IPv4, IPv6, DNS IPv4, and all three of them have a different way or a different address for resolving it. Then you'd really run into some issues. So in this case, what I did was something pretty cool. I actually did this in my office a while ago, and this worked pretty good. I remember a while ago I read about Cisco routers being able to perform like a DNS proxy. And all that means is the router on your behalf will go out and do these lookups for you, but then it'll cache that information. So that means the second and third time you use it, it should theoretically be faster. So I thought, you know what? That sounds like something good to test. So here's the commands that I use to configure my router. It's not very much at all. You can even add your own hosts if you want. It's kind of cool. And at the very beginning, again, I hit my router as a DNS server, and I didn't have DNS enabled. Again, I want to see what errors come back. And this is also a great way of testing a network, because if I know the device is going to send this, but in a corporate environment I never see this come back to me, then I know something along the way is blocking it. And that's a cool little trick that I use. Okay? Down here we have the router with the IP DNS enabled for the first query, and it took 45 milliseconds, which was the same as my laptop, so there was no difference. And again, I'm not expecting a performance change with the first one. But the second time I queried it, it was 1 millisecond. You see that? So it did exactly what I thought it was going to do. Simple. And this is kind of based on the theme of my conversation last week about baselining. It has to be concise. It has to be very, very easy to duplicate, and you need to know the methodology. Okay? So now let's get back to the MSFT NCSI. So when I looked into this, I've had to look at this many times for customers. This is the Microsoft Network Connection Status Indicator. So for the people who have a Microsoft operating system, in the bottom of your taskbar near your clock, you see a little icon to tell you if you're on the internet or you're not. And this is how Microsoft does that. They send out this little DNS query, and it's called active probing. Now, some people don't like this, and many people who manage DNS reports or whatnot see this kind of stuff come up all of a sudden, and they don't know where it's coming from. And when you don't know, of course, you assume the worst. Well, I'll give you some notes here. And again, I'm not expecting people to write this down. It'll be in the actual LinkedIn presentation. the SlideShare presentation that Denny uploaded. So this is the actual registry entry you can change to turn it off. Okay? So I'm just going to skim through that. That's there for your own reference. But the point is, don't just blindly do that, right? Because you might have an application that relies on that to figure out if you're online or not. So in most cases, I haven't had an issue personally, but you may just want to make one change at one time, like I said last week. Let's move on to ARP. And ARP, I love ARP because nobody cares about ARP. Poor little guy. He does so much work for us, a lot of heavy lifting. And even when you have an ARP, again, a command and a response, whenever you have a command and a response, you have the opportunity to measure response time, right? Period. It's that simple. It doesn't matter if it's TCP or ping or whatever. And in this case, you can see the ARP request goes out and the ARP response comes back, and it took 1 millisecond. This is extremely helpful. In some environments, you've got load balancing, either network load balancing, global load balancing, or physical load balancers that might change these MAC addresses. You've got some applications that use multicast or broadcast or fictional MAC addresses that you have to somehow figure out. So this is a great way to figure out what real MAC address is coming back. Okay? This also sometimes explains something called flooding. If these MAC addresses aren't in the proper tables, then you get flooding all the time, and that causes other sorts of issues for you. Again, simple, just a simple ARP. It doesn't take much to capture these packets. Okay? Let's move on to TCP, which now TCP, again, this is not a TCP session, but we're still going to cover some basics. Here you can see 2 basic packets. Now, for the people who haven't done this before, a little review. We're using this SYN and this SYN-ACK, which is part of, it's called the 3-way handshake. And this is what TCP uses to set up its connection. It's the most basic of things to look for. Now, if you can't find these easily in a trace file because you have thousands and thousands of packets to look at, you can simply in Wireshark search for SYN, and it'll jump right to it for you. Okay? Sometimes you have to use a combination of IP and TCP filter to get these. There's lots of different ways of doing that. But the point is, this SYN packet will go from the client all the way to the server, 74.208.29.25, and then it has to respond. And how long did that take? 48 milliseconds. This is not a ping. This is not ICMP. In some places, ICMP may be blocked. It might be spoofed. It may be rerouted. It may not even reply. So this is kind of a really good way of measuring, I'm going to call it the transport response time, if you will, just for now. Okay? So other things worth noting when you get this 3-way handshake back, and I do this a lot. I call it a TCP baseline. And I note what this WIN value is, W-I-N, and you can see it here, WIN 8192, WIN 14600. You see that? Whoops, I went to the next slide. Sorry about that. So you can actually note those, and it doesn't matter if you understand exactly what they mean right now. It's just worth noting, because in the future, if they change the operating system or the device or they apply patches, this number might change. So it's kind of important to have that documented somewhere. WS is a window scaling option, which just simply allows this number to get bigger. That's all I'm going to say right now. That's good enough for now. MSS is that maximum segment size, which tells you how much data you can put in that one packet or frame. And then we have SAC perm, and that means selective acknowledgments are enabled. And all SAC perm does for you in a nutshell is allow you to retransmit data more efficiently. That's it. I'm going to just leave it at that. That's good enough for now. Okay? So for the people who know a lot about TCP, you will argue with me that there's a lot to it. Yeah. But for now, that's good enough. Okay? In this example, me, 1044.1071, this guy here, packet 7, you can see I send that SYN packet, therefore all these parameters correlate to me. These are all me in my driver. And then obviously this acknowledgement is from the device that I was speaking to. Now the only thing you've got to be careful with in the real world is depending on how your internet access is set up, via proxy or natting or however you do that, this may not be that device. This could be some kind of intermediate device. So this might not really be the server that you're going to. Okay? But in this example, you can see I have this thing called SAC perm. The server doesn't. Well, good to know. And again, at the very beginning of baselining, and I said this last week, try to resist the urge to analyze. Nobody wants an opinion right now. We want facts. So just pretend, you know, remember, and the older people are going to remember just the facts, ma'am, you know, that old saying. Just get the facts. Don't worry about analyzing it right now. You have lots of time later to analyze later on and pontificate. Okay? Now we've made our way all the way up to HTTP. This is the application layer. And currently, I'm going to use that word currently because there's all sorts of stuff going on with HTTP. I'm going to just say currently it's .9, 1.0, and 1.1. And you'll see that in the header of that packet. You'll see get HTTP 1.1 or 1.0, that sort of thing. The only thing you really need to know, again, in a nutshell, we can do a whole other thing on this later, but for now, 1.1 brought you two big pluses. something called pipelining, which allows me to send multiple commands through one TCP connection, and keep alive basically keeps that port open, that TCP port, that TCP connection. So when you combine those two things, it makes things a little more efficient. Now, you got to be careful because this is a screenshot from Internet Explorer, and I've been at a lot of places where this HTTP 1.1 through proxy is not checked off, and they have proxies, which means that they use 1.0, the little less efficient version of HTTP. This is always worthwhile to look at, but again, if this is embedded in an app, or if you can't see these settings, you will quickly figure that out when you see a packet, and you can tell them how it's set up, okay? So I always try to set my browser for 1.1. Even if the proxy or the server or firewall doesn't support it, everything should still work fine. And then whenever they get to the point where they do support it, then good for them. And you know, and I always tell people, don't believe me, give it a test. Find out. Okay? There we go. HTTP response time. Drum roll, please. So now we're going to search and get only HTTP packets. Again, this is in Wireshark. Every analyzer is slightly different. HTTP. I'm also going to show you in a slide when you don't want to do this. But in this example, we're going to do this. HTTP. We find a GET, and we see a response. So this is one way of calculating HTTP response time. Now, some people will argue, what about the TCP stuff going on? And again, these are all different variations and different ways of measuring response time. This is one way, not the way, just one way. And basically, when you get this, you can see this guy came back at 50 milliseconds, and now you know. You also know that the customer sent out a GET using HTTP 1.1. You know the server replied with 1.1. If there is a proxy or a firewall between you guys, you know it allowed it through or supports 1.1, however you want to say that. So there's a wealth of information in just these two lines. Now, if you have multiple GET commands, the question is, how do you sort out which came back for which? And this is all going to be, unfortunately, specific based on your environment. But one way is if you have this e-tag value. And that's one way that HTTP provides web cache validation. And it's a unique string here. So you could have just said, hey, filter on this e-tag number, and you would have gotten the same two packets. Okay? Again, this is a general statement. You should find out in your environment what really works for you. Okay? Oh yeah, and in this header, when the response comes back, I can also find out it's Apache. See that? So in the future, when they say, oh wow, now it's gotten slower or it's gotten better, can you baseline this again? And you find out, oh, it's IIS, or it's Apache version X versus version Y, that sort of thing. You can compare, because I don't have to tell you this, but I'm going to say it out loud. When you ask your customers, what have you changed? Well, they're probably going to say nothing. So not that they lying to you, but they just don't know. They don't know what you mean by that. So this is one way to find out exactly what that means. Okay. Now, this is the other thing about response time. And again, this is not wrong or right. This is just another variation on that theme. You can again see the GET, and you can see the response. But then you see this TCP packet in the middle of that. See that? The previous example, I didn't have TCP in my filter. I only had HTTP. You see that? So this is key, and I just did a job last week where I leveraged this everywhere, and people were surprised because they were missing this. This GET command went out, hit the server. The server came back 49 milliseconds later and says, got it. Now, why didn't he send the data? Because he didn't have it. And a lot of times I'll see GET, ACK, and then another 20 or 30 milliseconds later the data comes out. So to me, this is the proof. The server got it. He's acknowledging it at the TCP layer, but at the HTTP layer, he wasn't quite ready yet. See that? Little spin on that. The only thing you got to be careful with is some network devices between you and the server might send these on its behalf or on its, you know, proxying kind of thing. So you have to make sure this really came from the server. And that's what I did. And I can't show you those traces, obviously, but I just did a job last week where literally I had a GET, I had an acknowledgement 200 milliseconds later, and then the data came out 300 milliseconds after that, a total of half a second. So it was really good to see it that way. And this all kind of explains what I just went through. Okay. So HTTP response time, you also might get a couple of additional perks, whereas in this case, Wireshark will tell you in this HTTP header, the request was in frame 10, the next request is 14, that sort of thing. And then it'll even say time since request. And it'll even calculate response time for you. But again, I caution you, if you don't know how it did that, then you may be looking at the wrong numbers. So again, I caution you to do your own math. It doesn't take much. And then find out how the applications are reporting it. And I'm going to say 50% of the time, your math is the same as theirs. But I'm telling you, every once in a while, no, they're going to do it differently. Okay, not wrong, just differently. I'm trying to make that clear. You should always validate the calculated time. Same, yeah, exactly. All right, so I said everything that I wrote. That's good. I'm actually following my own notes. Here's some example of HTTP agents. And when you send an HTTP GET or a POST, all these types of commands from a client, you'll see this user agent value inside that GET. And that's another good tip-off as to what is sending the packet. So for example, you see here Mozilla 5, Mozilla 4, Mozilla 5, but then you look a little further into it and they're all different. You have an Android device, Internet Explorer 8, Windows NT 6.1, you see that? So this gives you a great idea as to what sent it. Plus, if I wanted to only capture the web traffic from the Android devices, then I could filter on user agent, Mozilla 5.0, Linux, Android, See that? In this case, it even said HTC. Like it actually went a step further. So this allows me to have a different level of filtering, if you will. And again, as long as the tool, this isn't just a Wireshark thing, folks. This is an HTTP thing. So depending on the tool you use, you might be able to leverage this. Okay? Yeah, the last one was a good one. Windows Update Agent. This is what Microsoft sends out in its HTTP commands when you click Windows Update, and it goes and checks your update, that sort of thing. Wireshark has some helpful HTTP reports to help you go through this, so you don't have to do it all manually. Again, I'm strongly encouraging you to do it manually for the first one or two, and then when you believe it, then you do it. I'm also going to caution you, and nothing against the application guys, but things like Wireshark, when you get a new version, sometimes this stuff changes, either intentionally or not so intentionally, right? Like bugs and stuff. So it's kind of important for you to be able to say, wait a minute, that's not right. And that's why I always have a bunch of trace files I use all the time. I know the numbers off the top of my head, and I can quickly validate if that tool is doing it the same way. So in this case, it's saying HTTP requests, and it's giving me a list of all the stuff the page is pulling down. Okay? Here's a little reference. There's nothing really to say about this, but these are a list of all the commands that HTTP could have. But more than likely, you'll see these top three. I'm going to say generally speaking. You might see these other ones, but these top three. I've also added the RFCs here, just in case you can't sleep at night. You know, you got something that'll help you out. You can read that out. We've got our status code categories, and this is also relatively important because Telnet, HTTP, FTP, all these applications have these status codes. And you know what? Big tip. A lot of them have the same categories. So that's good to know. So this isn't just an HTTP thing. For example, categories 4s and 5s. That's what I go fishing for when there's a problem. And that will tell me if the client's not happy or the server's having a hard time. And that's, if you're lucky, you're going to see that. Server busy. Hey, look at that. Guess what? The server's busy. Like, you know, problem solved. So that if you're lucky, you'll see that. But that's something that you should have under your belt that you should be aware of. And not just, again, not just HTTP. This is more of an application thing. Okay? Here's some example of the codes. Again, I'm not going to read them all to you. I've actually put some references for the RFCs that correlates to some of them. And now, if you're lucky enough, some of the tools, again, this is Network Instruments Observer. This is showing you the same thing I showed you in Wireshark. And again, with Wireshark or Network Instruments, if you do click on something like a JPEG, it will actually rebuild that image, and it gives you an idea. The best example of this I can show you is, actually just tell you about, is an insurance company last year. Their internal
That's a shame. We've lost him.
Yeah, he'll be back in a minute.
Yeah, I was waiting for that.
we should have some kind of pool.
No,
when this thing drops off.
it's Tony's way to making sure that we're awake.
Yeah,
So
Tony.
that worked.
You like that, right? Very dramatic, wasn't it? All right, let me share my screen again. Sorry.
Anything to wake people up, Tony. I know you too well.
Yeah, that's right. I did that on purpose. All right. Okay, dokie. So here we are. So in this case, it will rebuild that image, and that story I was telling you a second ago. This insurance company, their internal web page took over, I'm going to say over 2 minutes to load internally, and it's their own internal web server. And when we did this exercise, we found that the images on the page were all high res. So you had multiple 8 to 7 meg photos on that web page that had to be rendered every time somebody went to that page.
Wow.
And all they did was, literally, the webmaster grabbed the corners and visually made the picture smaller, but didn't actually change the resolution of the photos. Okay. Nice, huh? All right. Credentials. This is a little tip. In most protocol analyzers, if you go search for the word credentials, if it's case sensitive, you're going to have to use a capital C. If it's not, you can use a lowercase c. And that will typically, if they're using something called basic authentication, base 64, most analyzers will decrypt or decode that, and you will actually see the credentials. And this isn't a bad or a good thing. I tell customers all the time because people jump to the wrong conclusion. I said, we're just figuring out how it behaves. If you don't like that and didn't know that, well, now you know, and you can go change that. Get it? And that's the kind of thing I tell people. We're just telling you the facts. I didn't write the app, and don't shoot the messenger. I'm just trying to help you understand it. Okay? So some simple baseline items to document. And here's I'm going to say your general list, and of course everybody's going to add and take stuff out, and that's fine. So you got your client IP address, the client HTTP version number. I'm telling you right now, if you keep seeing 1.1, don't skip this step. I'm telling you, this comes into play a lot of times. Server name, server HTTP version number, the HTTP errors if you saw any, total bytes, and so on and so on and so on. Instead of reading them all to you, I'm going to show you an example. So here's an example I did to CNN.com, and I just did this the other day. Total bytes, 2.8 megabytes. It's kind of important because if you're on a remote office or on Wi-Fi or working from home, then some of these sites can be explained when you see the total amount of traffic you have to download just going to the main page. Number of DNS lookups, I'm not making this up. There's 250 of them. Nice, huh? TCP response time to the server, and then the DNS response time to my DNS server. Okay. And then what I do is I always pick like the top 5 or top 10, and I basically say, okay, so the top 5 guys, what's their IP, what's the total number of bytes, and what's the response time? And then bang, 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 and that's what I do. Okay. That way, if there's one IP address with a lot of data, like an extreme amount of data, or a really high response time, guess what? You can clean that up. Okay. Here's another way of actually displaying that same data. And again, I didn't put all 250 on here, but you can see which IP generated the most traffic. Now, this also brings into play a conversation that I try to have with people called a dependency analysis. And what I'm trying to say to people is the number of devices required to build the web page will affect the total user experience. So obviously, the more IPs I have to talk to build the page affects DNS, affects TCP, and of course, there's more data. So this sounds, or may sound, relatively obvious, but it's a very, very critical point. And don't forget, you're only as fast as your slowest time. So if on your web page you have to pull down an image from one site that has a terrible response time and a lot of retransmissions, some of those web pages will either hang or you'll see a little box with an X in it and it's not quite done yet. Well, the user's waiting for that, right? So don't skip stuff. And I can't stress that enough. Don't skip stuff. You can also use the built-in features in your web browser. This is a big eye-opener for people when I show them. Chrome has something called developer tools in your browser. You don't download anything. You've got this right now if you have Chrome. Okay? This will show you all the images or files that you're accessing. Did you do a get or a post or a head or whatever command? What was that status that came back? Remember that? So you'd see the status is 1, 2, 3, and again, 4 and 5 aren't that great, so we kind of want to look out for those. Then it tells you the size. So those images at that insurance company, I would have seen 7 meg, 6 meg, that sort of thing. And then timeline. How long did that take? So you visually have a representation. Internet Explorer also has its developer tools. It's kind of nice they're all called the same thing. And same deal. You got a list of all your URLs. Again, this is all the same stuff, same information. To take this a step further, this is the kind of information you get in a lot of the application monitoring tools out there, okay? Those APM type tools. But now, again, you've got this on your PC locally. You don't have to buy anything. This is there right now today, okay? Let's talk about a little problem I ran into that I'm going to bring up because it's a simple test. Again, it leverages this three-way handshake we talked about earlier. And the client went off and tried to connect to this web address. And there's my SYN and the SYN-ACK coming back. And again, this 512 wasn't really from that server. This was from their combo proxy, firewall, NAT, blender, shaker, juice maker box. And the MSS was 512 bytes. So that's not the end of the world. It just means that we have to send 3 times as many packets, approximately, as we would have if we had a proper-sized MSS. And you see it here in the data, 566 bytes, 566 bytes. You see that? And that's what it is, that 512 plus the data, total length's going to be 566. And that's going to explain that. Well, this was a great one because every once in a while, this all-in-one box would kind of have some issues and would send back this maximum segment size of 2 bytes. And then when the clients try to send their commands out 2 bytes at a time, either A, it's extremely slow, or B, their PCs reboot. And that was brilliant to see. That was like scary stuff. That belongs in some episode of a ghost story. So in this case, this was not the web server. This was the device between you and the web server. Okay. And that's it. So I tried to keep that relatively short and sweet because, again, I'm trying to keep within the confines of our time. And there you go.
Thank you, Tony. And so why don't we give Paul a chance to spell check his list of questions. And then let me welcome Chris. Chris actually got on halfway through the show. Hi, Chris.
Hey, Denny. How's it going? Sorry I'm late today.
I noticed that your suit is hanging in the back. So you're not working today?
Sometimes I have to, dress up for certain things. And this is not one of them.
Yeah, it's good seeing you. Hey, Paul, so what do you got for us today?
Oh, just the usual, few questions. A great presentation, Tony, really good. First comment is just support for what you said about non-standard response time measurements. Very frustrating. I mean, when you look at some other tools and you try and find out exactly what they are measuring, it's very poorly documented. It says, oh yeah, this is the response time for the HTTP GET, and you think, yeah, but what are you actually measuring? And so I'm in total agreement there. That's a one that you really have to be careful of because there doesn't seem to be a standard way of doing it. The one thing I was going to raise was dangers if you have TCP segmentation offload and you're doing a tracing, you're running a trace on the PC, but the TCP is being offloaded by the card or something. You get what you see in your trace is not what's actually flowing over the network. The first time I ever saw it, it totally threw me because I ran this trace and I started to see 16K packets, and I was thinking, my God, what on earth is going on? And then that's when I discovered TCP segmentation offload. The other thing I had a note on was that a lot of web apps these days seem to do this thing where they do post data, the response from the server is a redirect, then the browser does a GET to get the redirected data, and then you get the data back. So in fact, you've got this double tripping across the network. So you need to look at both parts of that if you're trying to match that up to a user's problem. 500 status messages, back-end failures, SQL databases and things that sit behind the web server, they often cause, if the web application hasn't been written in a way that detects it properly, sometimes all that happens is it just throws a 505 at the user. Sorry, I'm getting a bit of an echo here. And you need to be clear on what the user's complaining about, because if they're complaining about the page first appearing, so if it takes 30 seconds for the page to appear, then obviously you're concerned about one particular get or post command. If they're complaining that then the page doesn't render all the images, then obviously you're worried about all those other things that it's going and getting, just like you said, and that's a good point. My final point was around the use of Fiddler in replacement of development tools, because Fiddler gives you a trace, whereas development tools just give you a point in time.
Yeah,
that's it.
Yeah, excellent. Yeah, as a matter of fact,
I had to run through that quickly because I should really leave right now, but it's okay. Let's push it a bit.
This is a good time to catch Paul. That way you didn't have a whole list to go over.
Yeah. Yeah. Okay, I'm done.
Thanks, Paul. Hey, Chris. I think you came in and saw enough of this. Just wondering if you have any comments or comments in general. This is the second baseline episode that Tony has done. Thought maybe you can share some of your thoughts with us.
Your microphone's not on, Chris.
Yeah. Yeah. It's this. Well, let's see.
There.
There you go. Nope.
Nope.
Well, we can't hear you yet. So work on that, Chris. So Tim, what do you think?
Well, I think this is great information. Matter of fact, I got my Wireshark up right now, and I'm looking at all the traffic, HTTP, the ARPs, everything. I'm going to be doing
even an old dog can learn some new tricks, Tim.
Rough. Yep.
Can you guys hear me now?
Oh yes. Hi, Chris.
Sorry.
Yeah, no, it's okay. Go ahead.
Sorry about that, Denny. Were you asking me about I came in late and all that stuff?
No, yeah, I was just wondering if you caught enough of it to share with us your thoughts.
Just a quick thought. Just one thing I was thinking, Tony, with the something that I run into from time to time with the I think you described it HTTP response time between a get and a response.
Mm-hmm.
Like if you say get HTTP 1.1 200 OK. Sometimes I forget to tell people that have the default Wireshark installed that typically that reassembles the TCP. It does the TCP reassembly thing.
Oh, right.
And then it puts the 200 OK at the bottom of the response instead of as the first packet. So that time would also include all of that data transfer time.
Yeah, good point.
That's just something I sometimes forget to tell them.
Yeah. Cool. Awesome.
So disable that if you want the HTTP response time to accurately represent time between request and response. That's something to disable in the preferences for those that are watching.
Cool.
And rather annoyingly, if the application is posting a great deal of data to the server, so you've got multiple packets in the actual request, then as Chris said, that if you've got segmentation reassembly set, it measures from the last of the requests to the last of the responses. So even then, you're not getting a true end-to-end view, which is, and then if you switch off the reassembly, you get first request to first response. You still don't get the whole thing.
Right.
Yeah.
And thankfully,
that's why we wrote that transum thing. That's what that does for us.
Right.
Okay.
Good. Out of the way. Great job, Tony.
Thanks, man.
Excellent. So, well, the next one might be challenging, huh? Because it looks like you're going to be busy again. But
yeah, yes. Unfortunately, the floodgates opened and the work came in, but we'll make time for this. There's a lot to talk about, so I'm going to pick some more topics. I got lots to choose from. Just a matter of time.
So are we're gonna continue with the baselining for a little while? The baselining topic for a little while.
I'm sure Paul and Chris will agree that this is scratching the surface. There's lots to get into.
Yeah.
Yeah.
I look forward to that. And so before we sign off, so Chris, is it time yet for you to do a newbie episode? I mean, this LMTV Pro series has just been hitting out of the park.
Awesome. Yes, I think it's time to get another one scheduled. So we'll
Okay.
for sure chat about it.
I'll work with you offline. So just
Okay.
for those of you who are watching, we got a lot of good stuff coming up, and the next one might be Chris Greer. Okay. So with that, I'm going to sign off, and it's Friday. It's Friday. So go out there, and in fact, for Paul, it's already done. He's already done for the week, right?
I'm finished.
Yeah. Okay. Well, have a great Friday, and have a great weekend, everyone. Thanks again, Tony. Thanks, Tim. Thanks, Paul.
Job.
Thanks, Chris. Great job.
All right, guys.
Great job. Really enjoy it. Okay. Bye-bye.
Take care.